section 5. Direct variation. So direct variation, just kind of talking about what it means. It's talking about how x and y vary directly with each other. For instance, if you go and fill up your car with gas, let's say the gallons of gas that you purchase is your x, and the cost of it is your y. One affects the other. Y is directly, varies directly with x. Now, at a constant rate, and that's what we need to understand. So a constant rate is what we need to find. What is that constant rate if x and y vary directly with each other? Okay? So, here's the formula, y equals k times x. K is the constant of variation.
Why'd you put negative k? Yeah.
I did. That's just a bullet point. Okay? So, what k really is our slope. Because this is going to be a straight line. And where every direct variation begins, let me let you answer the question. What happens? You go to the gas station, you don't buy any gas. So what number is that? 0. Everything starts at the origin with direct variation. Well, not starts. Every line will go through the origin if you have direct variation. Notice there's no plus b here. Y equals mx plus b. What would b be? 0. Okay, so it's always 0 with direct variation. So it's always going to go through the y-axis at 0. That's what's special about this. All right, so now we have what I just said. The graph goes through the origin. What you just told me, b is 0. And one last thing. Since we are finding or trying to know what the slope is, because we want an equation where we don't know x and y, so we can plug any value in for x and y. And leave those variables in the equation. We want to solve for k. We want to know what k is. If I want to solve this for k, what would k equal? How would I get k by itself? How do I get rid of the x? Yeah. So you would have y over x. So all you need to do to find k is find a point on your graph, or whatever coordinate is given, and put the y over the x. And that is your slope. So we'll do some examples so you understand what we're doing. Direct variation is actually very simple. Now we're not doing any application right here, like the gallons of gas purchased and the price that you paid. That would be an application of direct variation, yes. No. Well, it's possible. I mean, they've already done direct variation, but they also have inverse variation. But today we're just talking about direct variation. Okay. So let's just do some simple examples, work examples of direct variation, and then we can talk about application later. All right, so I want you to write the equation given a coordinate. So you're gonna have to write this as your answer, but with a value for k. So I want an equation when I'm given this as a coordinate. So what's x? What's y? Got it? Was that what you're going to say? Okay.
So,
So x is 3 and y is 12. So what is k then?
12.
Brianna? What'd you say? 4. K is y over x. 12 over 3, which is 4. Alright, so now I want a direct variation formula for all of the values of x and y where k is 4. So now all you do is fill in what k is for all values of x and y.
That's the answer.
So if you want to look at this as a graph, which you're not necessarily graphing this, I'm going to show you. It goes through the origin, right? This b is 0. And what's my slope? As a fraction? 12 over 3 or 4 over 1. You have S 4 over 1 here, up 4 and over 1. And that would be the graph. I'm not sure in some of your directions if it says graph, but mostly you're just going to give me the direct variation formula. Yes?
You wouldn't go 3 divided by 12,
No, it's y over x. Okay?
Yep.
Alright, let's do another one. Make sure you got this. Example 2. Y is 5 and x is 10. Write that in direct variation form. Just like we did on example 1. Okay, so k in this example is y over x, or 5 over 10, which is 1/2. Yeah.
Oh, y equals 1/2.
All right. So either given it as a coordinate, or just written as what y and x equal, you ought to be able to tell me what the direct variation formula is. Okay? All right. Example 3. Let's see if you really got it. I want to see how many people can get this. Y equals 4, x equals 12. Put a direct variation, write the equation. Okay, so let me see a couple of mistakes. Most of you got it right. So k is y over x. Everybody watch this. That's 4 over 12. I've seen this throughout the year, and for some reason you all want to say that, well, not all of you, some of you want to say that that number is 3. Well, 3 as a fraction is 3 over 1. 3 is bigger than the 1. Well, the 4 is smaller than the 12. So when I reduce this, the number on top should still be smaller than the one on bottom. So really, this is not 3 over 1, it's 1 over 3. So for some reason, you guys that always want to put the bigger number on top, stop doing that. Okay? And if you have to reduce the long way, do that. I can reduce both of these by 4. Reducing is division. 4 divided by 4 is 1, and 12 divided by 4 is 3. Okay? So now my answer is y equals k, which is 1/3 x. Do not put k here. K is here for this formula. All right. Now, example 4. I'm going to give you 4 equations. You write down all of them and then write yes or no underneath the ones that are in direct variation form.
So like if they work out together?
So identify which ones are in direct variation form. Write all of them down.
That's the boss.
Which one?
The y equals 4 is that
Pi symbol, yeah. What pi looks like. Yes or no? Which ones are in direct variation form?
Oh!
All right. Is this in direct variation form?
No.
No, because that right there. Is this in direct variation form?
No.
Why not?
Because it's over.
Yeah, the x is in the denominator. This is actually inverse variation. Is it 4 times pi? Doesn't that give me a number? So this is still a constant number. So y equals something times x, y equals k times x, that is yes. And this one? That one's the obvious one. Alright, so let's look at the application problem real quick. Alright? First of all, you need to be able to identify what is y and what is x. So you're going to the gas station. What is your dependent variable and what is your independent variable? Which one depends on the other?
Price.
No, not yet. Just in general, y and x. We talked about this this past fall, and we've been talking about it most of the year. Y always depends on x because aren't you always inputting a value for x? So we call our y variable the dependent variable. And on a graph, this is your y-axis. So now let's identify which one of these depends on the other. And that would be your y value. Which one? Price or gallons? Price depends on how many gallons you purchase?
Yes.
Okay, so this is my y variable and that's my x variable. So price is over here and gallons purchased are over here. And now you will see when you don't buy any gallons, it doesn't cost you anything. So there you do see that it does go through the y-axis and 0. Now we got to know the price. Let's just say that it's $4 a gallon because it's very close to that. So we're just going to write this up here. That's your unit rate. Remember, anything over 1, that's going to be your unit rate. $4 per 1 gallon. So I got 1 gallon. What's my price? 4. 1, 2, 3, 4. If I buy 2 gallons, 8. It's a straight line. It goes on up. I'm not going to buy negative gallons. So on my graph, I'm not going to continue over to the left there. So what is my direct variation formula? What are you thinking of to get it? What do you need? You need k. So y equals k times x. I need to know what the constant of variation is, or the slope. K is y over x, or you said price over gallons. What is my price over gallons? $4 over 1 gallon, or 4 over 1 is my k. So y equals 4x. So there's an application of direct variation, where you have a constant rate of change. Okay, you are told when you go to the gas station, it's $4 per gallon, no matter how many gallons you buy. They're not going to change it. You know, you get to 10 gallons, and oh, we're going to change it to $2 a gallon. That'd be great, but they don't do that. Yeah. No. Yeah.
On example 4, how is the second one now?
This is just a number. 4 times, you can tell me what 4 times pi is. So it's just like this, that's a number. Right? Y equals something times x, y equals something times x. Well, this is not y equals something times x, this is something divided by x.
Okay, so like if it doesn't have a number in it, it's like a no.
If it's not something times x,
Okay.
this is something times x squared. So this is a square on your x, this is not direct variation. Okay. Alright. Assignment. Page 365, 1 to 20 all, and 26 and 27. Begin. Today's the 12th.